Imagine a computer that is as small as a room, or even a desk. As much as this sounds like pure science fiction, a simple idea you find outrageous, it is in fact true. Joking aside, we all know the power of our phones and computers. Even our cars and fridges have advanced computing power. But what I want to know is how we got here. And lucky for me, this is the topic of the video today. As from the womb of Intel came out their beautiful firstborn, the Intel 404, the first commercially available and produced microprocessor. You see, before the CPU, which contains all the essentials to operate a computer on a single chip, things were not so simple. Before the 404 computers were built, or computers with a CPU, they had to use multiple chips or even discrete transistors. The end product was a computer that sucked in more power than the latest crypto scam and would set you back as much financially than if you had fallen for the rug pull. Power hungry, bulky, and expensive. Most normal folks at the time would have probably never even used a computer, so much as seen one. But with the passage of time and increase in knowledge, as well as the mastering of the MOS, see the previous video if you're interested in that. I'll show it on the screen unless I can't figure out how to do that on YouTube Studio. Anyways, the MOS made the microprocessor possible, and Intel took notice. An entire computer on a single chip was possible before the CPU, with the previously mentioned MOS transistors, which were smaller and cheaper and much more reliable than their older brother, the bipolar transistor. The major key difference, however, between the two was that unlike bipolar, the MOS could be packed onto a single chip with hundreds or even thousands of the little doodads. MOS LSI, or metal oxide semiconductor large-scale integration transistors, saw their first use in 1967 within aerospace and military systems. D200 computers used MOS LSI for navigation and guidance in Minuteman missiles and the historical Apollo spacecraft. Although big and girthy tubes of metal flying through the air at high speeds made people scream in both terror and excitement respectively, the one use that I think was far more important and far less exciting was calculators. Calculators had become popular in the late 1960s, however most were mechanical, making them slow, noisy, and sometimes, much like their human companion, they could and would make errors. A calculator making occasional errors is like having a washing machine that each time you use has a 10% chance of setting your clothes on fire instead of washing them. Seeing this as not good, some calculator companies started to develop electronic calculators using the MOS LSI chips. But they also faced their own set of issues. Each model of calculator required a different set of chips to perform their different functions, making electronic calculators in their early years complex and costly to manufacture. However, this didn't stop them from trying. One of these companies was a Japanese calculator manufacturer named visicom. And if it feels like I've gone off track from the topic of the 404, this is where the previous stuff I just mentioned started to become relevant. See, in 1969, visicom, like a man in a white van, approached the young Intel, which at the time was only 1 year old. But instead of offering it candy, it offered the young company, founded by two engineers, Robbie Noyce and Gordon Moore, who had quit Fairchild Semiconductors to start this far greater business venture. Visicom wanted Intel to supply them, and unlike your supplier, who charges way too much for laced weed, Intel had to actually contribute to society in a meaningful way, instead of just sitting in their parents' basement covered in Cheeto dust. And also, unlike your supplier, it wasn't Cheeto chips visicom had the munchies for, but instead 12 custom chips for their new line of calculators. Intel agreed right away, but were stuck on how to move forward. You see, being 1 year old came with drawbacks. Their skulls were still slightly squishy, their cognitive developments were lacking, and they also lacked enough engineers or the resources to make 12 different chips, unless Visicom was okay with waiting decades. They were not. Intel would still push through, and the day was saved when a man by the name of Ted Hoff came riding in like a knight in shining armor. Hoff was an engineer at Intel who was assigned to work on the visicom project. He probably was smoking some of that smart weed when he came up with a brilliant plan. Instead of designing 12 separate chips for each calculator function, he could instead smush them all together into one general-purpose chip. The chip, instead of having to be physically designed with a specific use in mind, could instead be programmed to perform any function by just changing its code. Hoff eagerly showed off the concept of visicom and the management of Intel. The bigwigs at both those companies were a little lost and unsure of if this was the correct direction to go. However, with little options, they hesitantly gave the go-ahead. With the green light now set, Hoff was off. However, he could not do this alone, so he teamed up with another engineer, Stanley Mazer. Now, with double the manpower, they worked together to develop the instructions and architecture needed for such a microprocessor. Things were going good, but there was one last piece of the puzzle and person needed. Frederico Fagan. Despite having a name that sounds like an edgelord's Lord of the Rings LC, he was brought onto the project due to his expertise around MOS LSI design. Fagan was responsible for taking the ideas and concepts sketched up by Hoff and Mazer and putting them into a physical plane of reality. Now with a physical chip done, the name 404 was given. The 4 in the name represented the fact that the microprocessor was a whopping 4 bits and contained 2,300 transistors. It boasted a clock speed of 740 kHz, which could perform 60,000 instructions per second. Of course, in the modern lens, these specs seem doo-doo garbage. But it did succeed as it could do basic arithmetic and logic operations. The ability to perform such tasks meant that the 404 had been successful in its mission to be a chip capable of calculations. The 404, although having many of the essential components that the 12 chips would have, still needed 3 other chips. The first of these chips was the 4001 ROM. ROM standing for Read Memory Only. The 4001 ROM chip served as a way to store program code. The next chip they needed was the 4002 RAM. You may know of RAM as it's used in the computers of today. However, you may not know RAM stands for Random Access Memory. And in the case of the 4002 RAM, the chip was capable of storing data. The final chip needed for the 4004 to be more than a bit of Chinese plastic in the garbage patch was the 4003 shift register. The shift register was what handled the input and output of the calculator, making it so a human could actually interact with the various programs. With all these chips combined, a fully functioning calculator could be created. Intel was not the first to make microprocessors, or even think of putting them in calculators. Multiple other companies were making microprocessors of their own around that time. These companies include Texas Instrument, Garrett AI Research, Four-Phase Systems, and NASA. However, as said in the beginning, the Intel 4004 was the first microprocessor to be commercially available and widely used. Although the 4004 was made for visicom and their new lineup of calculators, Intel cleverly saw the potential use cases of this chip were far more broad and wide. Intel, feeling like they just made a large mistake, as during the deal, one of the agreements was that the 4004's rights belonged to visicom, they nicely asked visicom if they could buy it back. Luckily, visicom was in a happy mood and agreed, and they signed a deal allowing Intel to keep the rights of the chip. However, in exchange, visicom would receive a lower manufacturing price per chip produced. Now with the rights of the 4004 back in their pockets, Intel was free and would quickly start to market the chip to various other customers and industries. In November of 1971, the 4004 was publicly announced in the form of an advertisement within the paper Electronic News. The ad proclaimed, announcing a new era in integrated electronics. A bold title and ego to match, Intel was riding high. And their claims were not overpromised, unlike many of the AAA game studios we see today. The 4004 was sold for $60, the equivalent of $450 in 2023, which seems fairly pricey for the performance it was giving, but compared to other conventional computers at the time, it was a fraction of the cost. The 4004 only had a brief spec in its actual runtime as quickly it was followed up by the 8008. Keeping to the naming convention, the 8008 carried a respectable and still weak 8 bits of processing power and had far more use cases than the 4004. But the 4004, in my opinion, is more important, as it sparked a computing and an electronic revolution. Many products previously thought impractical or even impossible, such as personal computers, video games, digital watches, traffic lights, music synthesizers, and industrial controllers, as well as so many other random things, could now feasibly exist. Existing devices also saw a major boost with the 4004's help. As mentioned before, there were calculators, but on top of this, terminals, printers, cash registers, and like I said before, many other random things saw a reduction in their power consumption, size, and cost. The 4004 also had a large internal impact. Intel pre-4004 was just a small semiconductor company. Post-launch, it became a global leader in computer technology, having its revenue grow from $20 million in 1971 to $1.9 billion in 1980. In the late 70s, Intel's market shares of microprocessors was over 90%. These successes spawned a pool of competitors such as Motorola, Zlog, MOS Technology, and AMD, who are all eager to dethrone the new king of tech. And like Intel, these companies push the boundaries of microprocessing and its technology. With huge sale figures and many new products being aided by the 4004 CPU, the social and cultural impact was bigger than 9/11, and unlike 9/11, it was well received, making millions of us bummy commoners capable of owning computers. With computing now in the hands of millions, new forms of communication, education, and entertainment sprung up. But as the world was going through its tech puberty, many concerning changes took place. New ethical, legal, and privacy issues, as well as intellectual property rights, would come along for the ride. Some thought computers were the best thing ever, and automated or made simpler many issues thought too cumbersome for its human counterparts. Others, however, saw the computers as the Antichrist itself and believed they would be the downfall to humanity. Both sides were right. To contextualize the fears and hopes that were going on during this time, look to now. Some of you may have already noticed it is not too unlike the developing world of AI that we see ourselves in today. But everybody on either side could agree that the Intel 4004 was a remarkable invention, which changed the course of history. If not for visicom's challenging request and Intel having to find a creative workaround, we may not have seen the computer industry become as prominent today. And to think all this change was headed by three men, Hoff, Maser, and Fagan, who were given the goal of just making calculators not suck and not cost multiple organs. And along the way, they ended up creating the blueprints for a piece of hardware so versatile that you can see their impact in every piece of tech that came out since the launch of the 4004. Because of this, the Intel 4004 is now recognized as one of the most important inventions of the 20th century. It is part of a permanent collection in the Smithsonian Institution and has been honored with several awards and honors, such as the IEEE Milestone Award in 1996 and the National Medal of Technology and Innovation in 2009. The Intel 4004 is celebrated every year on November 15th as Microprocessor Day. The Intel 4004 was much more than a bunch of silicon and metal. It was a milestone in human history. And with it being such a leap in hardware, the software would need to catch up. And soon, the first graphical interfaces for computers would emerge. But that will be talked about next time.
Help, my stomach is so full of yummy pie. Oh no. Now I am become explode. Exploder who's exploding.